Hi, I'm Richard. The title of my PhD is House Diagnostics, Non-Invasive Domestic Building Thermal Performance Measurement. I'm nice and snappy. I'm in the third and, touch wood, final year of my PhD. So my project is about domestic buildings and their thermal performance. The reason I'm interested in that is that domestic buildings account for about 1/5 of our emissions in the UK, which is about the same as coal-fired power generation. So it's a big problem. And an interesting thing about buildings is that although they appear very similar, they tend to vary a lot in their performance because of the individualities of how they're put together. So they create a really nice arena in which to do measurement, and I wanted to do measurement for my PhD, so that led me down that line. We've heard a few things today about performance gap between what we think we're going to use in energy and what we actually use, and how we actually use a little bit more. So a nice way to try and find out about that again would be measurement. So the problem with that is that the current sort of whole house performance test might be a co-heating test, and that's 2 weeks unoccupied, and ask yourself whether you want that for your house. It's not very likely. So I confess the initial title of my PhD was Rapid Diagnostics, and rapid got a bit tough. So I thought instead of rapid, how about non-invasive? So this is instead of doing something really quick and coming in for a day, maybe I'll come in and install some discrete measurement devices and then monitor your house's thermal performance, so the temperatures inside and the energy consumption, and from that can I detect the thermal performance of the house. So you won't notice it's happening, you can live your life normally in the house. So the way that I'm looking into that is, so it's a test using this discrete monitored information, and I'll tell you an energy balance in the house, so I know how much energy there is inside and temperature and how much energy you're using. So from this balance, you can detect the thermal performance of the house. But when the house is occupied, there's a number of complicating factors, like people opening the windows, people closing all the doors so you don't get circulation of even temperature distribution throughout the house, and all these complicating factors that nasty people introduce. So if we want people in houses, we might have to sort of try and account for them. So the way that I do that is take a test house, which is empty, but then simulate people's occupancy in it. And by adding in one factor at a time and then different combinations of them, I can try and tease out the individual influence of each, so that I can have a method which will account for those in a whole range of houses. And I think that might be a really exciting thing to have, because if you wanted to refurbish your house, you might want a really accurate estimate of what your savings are going to be to see whether it's worth your while. Maybe a housing authority has a number of houses and smart meters, and they're thinking, oh, where should I focus my energy? If you can have this little test, which you've got done in a whole range of houses, and think, well, this one's a nightmare, I'll focus all my energy there and get the most sort of bang for your buck. So you can see I've got some sort of initial results here, which a comparison of the performance of the measured heat loss coefficient with hot water releases. So that's hot water being released to simulate a number of occupants in the house, and then the internal doors being closed. And that's sort of an example of the whole suite of tests that I'll end up with, which will produce this really convincing answer, and you'll all be really excited by it next year. So thank you very much.